Conditional probability lab. You guys want to do that one?
Yeah, let's just finish it out.
Yeah. I like this one. This one was fun. Well, part of it. I like the diesel car one because that's the one where no, that was total probability. Never mind. Okay. All right. I'm gonna open the solution and zoom in. Okay. All right. A coin is tossed and a six-sided dice is rolled. Find the probability of landing on the head side of the coin and rolling a 3 on the dice. Okay, the probability that you'll get a heads is 1 out of 2. The probability that you'll get a 3 is 1 out of 6. All the events are independent. You just multiply those two. That gives you your probability. Pretty straightforward.
Yeah.
Let's keep going. After conducting a survey, one of the outcomes was that 8 out of 10 of the survey subjects liked chocolate chip cookies. If 3 survey subjects are chosen at random with replacement, what is the probability that all 3 like chocolate chip cookies? Okay. So let's take a look at the formulas for a second. I'm gonna refer back. It's also, guys, it's I'm actually like a week or so out from section 17 and 18. So it's not 100% fresh for me. So that's the other thing we just want to keep in mind. So I have to sort of refer back to my notes. Right. Subject is equal to, wait, hang on. Okay. So there's an 8 out of 10 chance that any given individual is going to like chocolate chip cookies. Okay. So because we're replacing, each selection is just going to be the same odds. So yeah, that makes sense. So the first person that we pick, there's a 0.8% chance that he's going to like chocolate chip cookies. The second person is still going to have the same chance because we're picking from the same pool and it has the same odds. And then third person is the same. So that's our probability right there. That's good enough.
Replacement means that you're putting back the original value that
Yeah.
you put up.
Yeah, that means that, so like, all right, so in the first round, all right, so it says, you know, what's the if 3 subjects are chosen at random, right? What is the probability that all 3 like them? So you choose the first subject. There's an 8 out of 10 chance. Let's say you choose the first subject from a pool of 10, right? But then you put him back into that pool of 10, and your second choice that you make is again from that same pool of 10 people, of which 8 like chocolate chip cookies.
Right.
Now, if it was without replacement and you were choosing 3, you pick the first one, right? There's a 0.8% chance that the guy likes chocolate chip cookies, but now you have 9 left for your second choice. So the odds are now different.
And it would also matter if they liked the one you pulled out, like
yes,
chocolate chip cookies or not.
That's exactly right. So if the first person that you liked them,
then it would be 7 out of 9.
Yeah. Yep. No, would it be 7 out of 9? It would be like 8 out of 9 because you already, I don't know.
No, if you pulled one that
that's true. Yeah.
only 8 that like it, so there'd be 7 left over.
Yeah, that's true. That's exactly right. Yeah, you're right. But if it wasn't, then I think it would be 8 because you've already picked the one guy that doesn't like it, which still leaves 8 guys who do like it and 9 people in the total pool. Okay. Yep. So that makes sense. Right. Exercise 3. 70% of your friends like chocolate flavored ice cream and 35% like chocolate and strawberry. What percent of those who like chocolate also like strawberry? Okay. It's pretty. Once you start plugging in the formula, right? Would you guys mind if I drew this one out?
Good.
I like drawing stuff out. I gotta get one of those drawing tablets. Okay. All right. Let's see. Yeah, and they write the formula out for you too. Yep. Um, so these are all my friends inside the square. 70% of them like chocolate. 35% like chocolate and strawberry. Okay. 35 like chocolate and strawberry. And then an unknown number of them like just strawberry and not chocolate, right? So this is chocolate at 70%.
No,
That's
that wouldn't be 70 because you have to subtract out the 45, the
that's
35.
very you're very right. You're very right. So that would be yeah, yeah. So this is the C complement. I'm
It would be
thinking
35 and
yeah,
35.
yeah, 35. You're right. Okay. Yeah, fair enough. But it'd be 70 for all of chocolate. And then let's see. And then this is X because we don't really know what that is, right? So what percent of those who like chocolate also like strawberry? Um, so I think we can just plug in the formula. The probability that they like chocolate is equal to 70, right, from the total.
Yeah.
Probability that they like C and S is equal to 35. And then the formula that we've been given tells us that, what does it tell us? Let's see. Yeah, probability of A given B, or in this case, it would be what percent of those who like chocolate also like strawberry, right? Oh,
That's 35.
what happened?
70% of your friends like chocolate, 35% like chocolate and strawberry.
Yeah.
Wouldn't it just be 35%?
No, it's saying what percent of those who like chocolate also like strawberry. So what that's doing is now
Oh,
it's saying
35% of 70.
no, not even. Kind of, kind of. So what that's doing is it says what percent of those who like chocolate also. So it's saying that we want to express. So now it's basically shrinking your universe down to just chocolate, right? So it's saying yeah, this area is what fraction of the whole C. And for that, I think yeah, and that's A given B. That's what that is, right? So because that's what I mean, like if we know that they like chocolate, then what are the chances that they like strawberry as well? And chocolate is kind of like now you're 100%, and we're trying to see like it's a bit of a unique thing. Like you can't really like it's not visible on the diagram. That's what I've learned about conditional probability. It's sort of like a hidden thing because yeah, what happens is that when you say A given B, you're saying that B is now our whole universe, and we want to see what's the probability of A occurring in that universe. So basically, like, you know, this would be C now, and we want to find the strawberry people. So the universe is all the people that like chocolate, and we want to see what percent of that universe is S. So it's 35 expressed as a ratio of this whole thing. And so the math behind that is probability of A given B, or in this case, I'm sorry, let's write it, probability that they like strawberry, given that we know that they like chocolate, so probability of S given C is equal to, and the formula is the probability that they like both strawberry and chocolate, right? And that probability is expressed as a probability of the universe. So we're saying that 35% of all of your friends like both of those things. So that means 35 out of your 100 friends like chocolate and strawberry. So, and probability of SNC, that's exactly what that is. So that's going to be 35. And then the rest of the formula is the probability of B. We're going to divide that by the probability that your friends like. So that's going to be 35 over 70. Right, so the probability that they like strawberry and chocolate. No, the probability that they like the probability that they like strawberry, given that we know that they like chocolate, is then going to be 50%. Was that helpful at all?
Yeah.
Okay. What is the probability of drawing 2 consecutive aces from a deck of cards? Okay, that's fairly easy. So let event A be drawing the first ace and event B be drawing the second ace. For the first card, the chance of drawing an ace is 4 out of 52. Very true. But after that, removing the probability is less likely because only 3 left. Yeah. So yeah, probability of A being we're going to draw an ace, and B given A is that we're going to draw another ace given that we've already drawn one ace. So the probability of that we draw an ace the first time and an ace the second time is the probability of A, i.e. drawing an ace the first time multiplied with the probability of B given A, which is 3 out of 51. And that gives us the probability of drawing an ace the first time and the second time. And that's down here.
Great.
Good enough? All right.
Yep.
In a manufacturing factory that produces a certain product, there are 100 units of the product, 5 of which are defective. We pick 3 units from 100 units at random. Oh, this one was messy. Okay, what is the probability that none of them are defective? Hint, use the chain rule. What the hell was the chain rule? Okay, I have the chain rule. Oh man, this was gross. I don't even want to do this right now. Ugh. Okay. Let's define AI as the event that the ith chosen unit is not defective, for I is equal to 1, 2, and 3. Okay. We're interested in probability that AI and A2 and A3. So note that probability of AI is 95 out of 100. What is it? Okay, so 100 units, 5 of which are defective, and we pick 3 units from the 100 at random. And we have to see what's the probability that each selection at the end we're left with 3 products that are not at all defective. So yeah, it's pretty straightforward, I guess. Yeah, the first chance is 95 over 100, because in the first selection, there are 100 items, 95 of which are not defective. We're picking one, and we want to see what are the odds that the first one we pick won't be defective. Easy enough, 95 out of 100. Then the second one is, well, now we're going to pick another item. We've already picked one, and the one that we've already picked, it was not defective. So now what are the odds that we're going to pick another item that is not defective, given that we have already picked one that was not defective? And that's going to make it 94 out of 99, because we have 100 things left to choose from, and the one that we already picked was not defective, so that also reduces the number of non-defective items in the group. So that's our probability, because in the second time around, we've already picked one item that was not defective, leaving us with 99 total items and 94 items that are not defective. And then the second one is the same thing, right? Now that we've picked 2 that are not defective, we're left with 98 total items, 93 of which are not defective. And then we're just going to multiply each of them by each other. That's going to give us a probability. There's an 85% chance that we're going to pick 3 items that are not defective. Good enough. Keep going.
Yep.
All right. Let's consider the example where 2 dice are thrown. Given that at least one of the dice has come up a number higher than 4, what is the probability that the sum is 8? Okay. 2 dice are thrown. Given that at least one of them has come up on a number higher than 4, what is the probability that the sum of the dice is 8? Okay. All right. Okay. Let this be the number of the events A and B are described below. I don't know what is going on here. Is it okay? This is also messy. Let's I'm gonna go switch over to mine. Were we on total probability? Yeah. No, we were on conditional probability. Oh. I might have to head out, guys, in a minute because now I got the monkey bugging me.
That's all right.
Yeah. Okay. Let's see. Where were we? Okay, that's the one, right? Exercise 6. Given that at least one has come up before this probability. All right, so let I and J be numbers shown on the dice, and then the events A and B are described below. Event A is when either I or J is 5 or 6. Okay, event B is when I plus J is equal to 8. Okay. What is the sample size? What is the size of the sample space? Well, that's going to be 6 raised to the power 2. That makes sense because that's all possible outcomes when you roll 2 dice. So what is the probability of A and B? Oh, I guess I didn't even finish that one. Oh, look at that. What is the probability of A and B?
They give probability B given A, but not A given B.
Or A and B. They don't tell us how to get A and B, but they seem to do it implicitly. Crap. Let's see now. 4 over is probability of A that's divided by, so A and B is 4 over 6. Now why is it 4 over 6? Is it because event A is when either those and then B is, yeah, they don't tell us why, huh?
Well, 4 over 36 is probably, the 36 is probably the 6 to the second.
Right?
So 4,
There are 4 outcomes that meet the criteria that A, either they're greater than 5 or 6, that, and then event B is that the sum of them is 8. And that means that there's 4 outcomes that fulfill that criteria. The question is why? Cut it out. Guys, I'm gonna run, but I don't know. I'm gonna keep doing it, or I'll keep the meeting. I don't know if I can leave the meeting running while I leave.
no, that's all right. I'm gonna check out.
Yeah,
All
me
right.
too. Thank you so much.
No worries, that was helpful.
Yeah, have a good one.
You too.